Okay, welcome back, everybody. We're going to talk about how to calculate surface area of a couple of the solids that we looked at in the previous lesson. We're going to be just doing surface area of prisms and cylinders today. Start out a little bit of vocabulary, and we're going to end up with some examples. First of all, look at the diagram that I have there. You see a triangular prism because the bases are triangles. They're congruent triangles. They're parallel. The sides of that solid are parallelograms. So the altitude of a solid or of a prism is the perpendicular segment joining the planes of the bases. So you can see right there the altitude is marked, has a length of h there. You see the two triangular bases and you see the lateral faces. So lateral means side, just like in football. A lateral pass is a sideways pass. So a lateral face is a face on the side of the prism. Okay, a little bit more vocabulary here. Let's talk about surface area. Surface area of any solid is the total area of all the faces and curved surfaces of a three-dimensional figure. So just all the area added together would be the total surface area. So that would be maybe if you like dipped the solid in paint, which surfaces would be painted. Lateral area is just the side area. So that's excluding the bases. So if you're calculating the lateral area of this shape you see right there, it would just be these three sides, not including the bases. So that's some terminology. And we'll do some calculations. You'll see how all this works next. We're going to be looking at, first of all, the calculating the surface area of a rectangular prism. So you see right here the orange rectangular prism. So the bases are rectangles, and again, they're congruent and parallel, and the lateral faces are parallelograms. In this case, they're rectangles. So you see my handwritten calculation there. Think of this as kind of common sense. I don't know if I want to memorize much of any formulas about this. Look, you got six faces, right? So look at my calculations. I got 2 times 6 times 8. Look at the base of the rectangular prism. You got 6 times 8 is a rectangle on bottom. So that area of that bottom is 6 times 8 is 48, but it's multiplied by 2 because the top and bottom of the rectangular prism are congruent. Then you see 2 times 8 times 12. If you look at 8 times 12, that's the front face here. 8 across and 12 up. So 8 times 12 is the front, and you got two of those because the back and the front are congruent rectangles. So we have that. And then next in my calculation, you have 2 times 6 times 12. So 6 times 12 is the right side, the right face of this rectangular prism. So the right and left faces are going to be congruent rectangles. So that's why there's two of them. Put this in your calculator, add them up. You're going to have 432 square centimeters for the total surface area for that rectangular prism. Okay, for something a little bit more challenging, let's take a look at the hexagonal prism here. It's this blue shaped right here. So remember when we talk about nets, so you can kind of cut that apart and spread it out, and you'll have the net for that prism. And the benefit of that is that you can see what shapes you're dealing with. So we're going to find the total surface area of that hexagonal prism. Let's start with the lateral area, which I called LA here. Remember that the bases of this hexagonal prism are both hexagons that are congruent and parallel, and the sides are going to be these rectangles. And if you look at each rectangle, it's 10 up and down and 6 going sideways. So you got 6 of those rectangles, one for each side of the base, and each rectangle is 6 by 10. So you get 6 times 6 by 10, or 6 times 6 times 10 is 360 altogether. So the lateral area, just these rectangles then, is going to be 360 square meters. Now don't forget to add in those two bases. They're both regular hexagons. And so if you recall, we had that kind of complicated calculation for the area of a regular polygon. I'm not going to go through all that today, but I put 2 times capital B. Capital B stands for the area of one of those hexagon bases. So it's 2 times, and we had 1/2 times apothem times perimeter. Well, the 1/2, of course, comes from the formula. The 2 comes from the fact that there are 2 of them. You can tell by the perimeter of this hexagon that each edge is 6, and there's 6 edges, so 6 times 6 is 36. This 3 times the square root of 3 is the apothem, which I'm not going to go through, but that would be the apothem. Remember, the apothem connects the center of the polygon perpendicular to a base. Put those numbers in your calculator and you get 187.01, or I guess, is that 10? That's 06 there, I guess it would be. Add up the lateral area, 360, plus the 187.06, and get 547.06 square meters for the total surface area of that hexagonal prism. So again, you can look at the net, and that'll help you sort it out a little bit as far as calculating the areas. Okay, let's direct our attention out to the cylinder. Cylinder, remember, is like a can of soup. It's got 2 circular bases, which are congruent and parallel, and then it's got a curvy side, I guess you could say. This is a little bit tricky at first, but I think you'll get it. So think of this cylinder then as being made up of 2 congruent circles, which you know that. So we're going to start out our formula down here. SA is surface area is 2 pi r squared, because each base is a circle, so it's pi r squared. So you get 2 times pi r squared makes up the 2 bases of the cylinder. Now let's say we took this cylinder and cut it. It's like a roll of toilet paper or something. Just cut it with a pair of scissors like this and unrolled it. If you took that tube and unrolled it, you would have a rectangle. And you see that rectangle right there off to the right. Think about the dimensions of that rectangle. That rectangle, you see, there's going to have the same height as that tube there. So I call that H, just like on the tube. And then if you unrolled that and flattened it out, that tube, you'd actually have a rectangle. And think about it. The length of that rectangle going sideways would exactly be equal to the circumference of that tube, 2 pi r. Circumference of a circle is 2 pi times radius. And you can see that right here. So if you want to find the area of that rectangle, it's length times width, it's 2 pi r times h. And that's what you see down there in my formula. So the formula surface area of a cylinder is 2 pi r squared for the 2 bases plus 2 pi rh for the tube that got unrolled and then added together with the bases. So that's going to be right there. That's going to be your formula for surface area of a cylinder. Okay. Let's do some calculations with the cylinder, and that'll wrap up our lesson for today. First of all, come in. There it comes. A little bit slow. First of all, take a look at our actual cylinder here. It's this one in part A, which is purple. It's a cylinder. It's sitting on its side, so it has actually a height of 5 meters. It's going sideways. The diameter of that cylinder is 2. So we're going to calculate the total surface area of that. Notice here the net of it's spread out right here, so you can see the net, if that makes it easier to help you calculate. I wrote up here on the top line the surface area formula for that cylinder. So remember, it's 2 pi r squared because of the 2 bases are circles, plus 2 pi rh. Remember, the 2 pi rh is the tube of the cylinder unrolled into a rectangle. So you really just plug in numbers into a formula here. So 2 pi rh, the radius is going to be 1, right? Because the diameter is 2, radius is half of that. So 2 pi times 1 squared. Plus remember that tube part was 2 pi times radius times height. So the radius again was 1. The height is 5, you can see there. Plug those numbers into the formula, and you got 2 pi plus 10 pi. Now this particular problem says leave your answer in terms of pi. So we're just going to say 2 pi plus 10 pi is 12 pi square meters. If they had said write your answer to the nearest tenth, of course, you'd have to put 3.14 into your calculator or use your calculator's value of pi to get a decimal, but they just said leave it in terms of pi, so we're just going to be happy with 12 pi square meters for the surface area, total surface area of that cylinder. Okay, so my last problem and my favorite is kind of interesting. Let's make this a little bit bigger. See it better. Okay, so this looks like some block of wood with a hole drilled out of the middle, and we're trying to find the surface area. Think about where the surface really is. If you took that block with a hole drilled out of it and put it in a bucket of paint, would not that paint cover not only the outside of the block, but also the inside where that cylinder hole is drilled? So that counts as the surface area, even the inside there. So let's think about how we're going to get that. So I got a little calculation set up there. You see it, SA surface area is 2 times. Now let's do the front of that block. So 24 times 20. You see that right there, 24 times 20 is that front face. There's 2 of those because you got a front and a back. So 2 times 24 times 20 is the front and the back. Then we got 2 times 16 times 20. If you look at the right side, it's 16 by 20 rectangle. So the right side and the left side are going to be congruent rectangles. So I put a 2 in front there. And then you got the top and the bottom, which are 24 across and 16 deep. So 2 times 24 times 16. So top and bottom. But now keep in mind, we got to take out the circle on top and bottom because that's drilled out of there. So we're subtracting now the minus sign 2 pi r squared because you got 2 circles. The radius is 4, so 2 times pi times 4 squared subtracts out the circle area that is not there because they drilled the hole. But now our last term is actually a plus term because even though we drilled the hole out of it, the inside of that hole is surface area of that block. It's the inside surface area. So that's going to be the tube of the cylinder, which remember is 2 pi times radius times height. Well, it's 2 pi, the radius is 4, so 2 pi times 4 times the height, which is 20. You can get that from the side of the block. So 2 pi times 4 times 20 is the surface area of that inside of that cylinder. Put all that into your calculator, and you're going to get a total surface area of 2770.1 square feet. Okay, pretty good problem. Let's do a quick summary of what we learned in this lesson and then put it into practice with some of the practice problems. We talked about the altitude of a prism or cylinder, really. We talked about how to calculate surface area being the total surface area is the sum of all the areas of all the bases and lateral area. We did some examples of calculating the total surface area of a prism. One was a rectangular prism, one was a hexagonal prism. And then we talked about how to get the formula for the surface area of a cylinder. So that's going to be on the cheat sheet that I'm going to give you. And then we concluded with a couple examples of calculating the surface area of a cylinder. Okay, that's about it for this particular assignment. Let's get some practice because practice makes perfect, and let's give it a try.